Assalamualaikum. Our member group name is Radioactive DECAY. Course code is Diploma Mathematics Science CS143. Group course is DCS 143 5C. Lecturer name is Dr. NORAZAM ARBIN. Assalamualaikum. My name is MUAZ bin MASDUKIN. MAT3 ID is 2021818064.
Assalamualaikum and hi, my name is FAIZ bin NORHISYAM. My matrix ID is 2021624664.
Assalamualaikum, my name is NABIL bin NASIB and my matrix number is 2021814346. Thank you.
From the selection topic, radioactive decay, the introduction is the radioactive decay is a process by which is stable atomic nuclear lose energy by the radiation. Radioactivity is the release of energy from the decay and the nuclear a certain kind of atom and isotope. The half-life is a measure of the stability of the reactive sustain. Next, the model of mass of MT of the quantity of the radioactive material at a certain time T. The rate of quantity radioactive is the total proportion quantity radioactive in the present at any time. And the equation right below, the rate of change of the mass MT0 equal to M0, where K is constant proportional to represent the M per dt decay rate. Next, using separable method from the equation dm per dt equal to negative km, the negative sign for the amount the radioactive disposed to decay. The right is the solution to the equation.
Problem statement. The half-life of radium-226 is 2590 years and the mass for the sample radium is 200 mg. So we get 3 questions. The first one, we need to find the formula of the mass for the radium that remains after T years. Next, using the formula of mass above, we need to find the mass after 1200 years and correct to the nearest milligram. Lastly, we need to find when will be the mass of the radium will be reduced to 50 mg. To solve this question, we need to come up with the idea that we will get from the statement, which is the first one, the mass of the initial radium is 200 mg, and then to find the mass after the half-life, which is 2590 years, we need to divide the 200 mg with 2 and then we will get 100 mg as the mass after half-life. Next, we need to find the rate of change for the mass with the respect to the time is equal to negative km, with k is a constant. Then we need to reposition the equation and we will get dm over m is equal to negative k dt. Then we need to integrate both sides. After that, we will get m is equal to a exponential negative kt. To solve our first question, we need to find the value of k first, with assuming the value of our t is 2590. Why? Because we already know the value of mass with that time is 100 mg. So we can substitute the value of m is equal to a exponential negative kt with 100 is equal to 200 exponential negative 2590 k. Why a is equal to 200? Because a is the value for our initial mass, which is 200 mg. So after some calculation, we will get the value of k is equal to 0.000276. Don't forget to substitute back the value of k into the equation back, which is m is equal to 200 exponential negative 0.000267 and then that's our answer. So to solve our second question, we need to use the formula that we get from the question A, which is m is equal to 200 exponential negative 0.000267. So we substitute the value of t with 1200 and then we will get the mass after 1200 years is 145.0672 milligram, and then we need to correct to the nearest milligram, which is mass after 1200 years is 145 milligram. So the last question, we need to find the time when the mass is equal to 50 milligrams. So we need to find t. So to solve this question, we still need to use the formula that we get from the first question, which is m is equal to 200 exponential negative 0.000267. So we substitute the value of m with 50 milligram, and then we will get the value of t is 5180.4722 years. So that's our time.
Okay, decay radiation happen when unstable atom change to become more stable, realizing extra energy as a particle or wave. The function related to decay radiation help us predict how fast decay occurs and how long it takes for half of the material to decay. These equations are crucial for understanding and handling radioactive substance safely. Learning about decay radiation is vital for using nuclear energy, developing medical treatment, and dating ancient artifacts using carbon-14. While we must manage the risk, the benefit in science and practical application are significant. Thank you.